This afternoon's panel is focusing on the research, and it's a big picture panel. So you can see everybody who's with us today. Joe will be joining us shortly as soon as he's able to make it down. But let's get started with some questions as well. First of all, these are from the questions that you had from earlier. So if you have more questions as we go along, please fill out your index cards and either hold them up or push them to the end. We'll be coming around to collect them once again. All right, first question. Will there be a list of different medications for epilepsy that could help better, and actually a list for the doctors? Wendy, did you want to take that one?
Sure. So I showed this morning, and we'll be glad to share the slides. Different groups, different individuals have tried different medications. Many of them have worked. Many different ones have worked. In general, the epilepsy is not a terrible, difficult to control for most cases, and so I don't know that we have a best practice per se. Valproic acid seems to be working very well for many people. I'm not saying you should switch to valproic acid. If you've got something that's working, stick with what you're working. But we'll be glad to make all this information, post it, and make sure any of your doctors can see it.
Yes. All right. And Dr. Chung, let's stick with you for a moment. This is a question from the previous panel as well. So this is one drug. Will they need additional for other symptoms? Will there be more than one or created? Yes.
So we don't know yet. Again, I know I feel like a broken record and I feel like I'm an idiot, but we really don't know yet what the impact is going to be, and so we're going to have to carefully observe. In my fantasy world, this is something that's affecting the brain holistically, but I don't know what's going to happen, so we shall see.
Okay.
Can I?
Yes.
I just want to add one more thing, that while we're doing the clinical trials, we have our team continuing to screen against other potential drugs, whether they're FDA approved or in the process to kind of try to identify a few more to bring them back to becoming perhaps candidates for other trials. So this is one, but we're continuing to, find others until we have like that custom designed one that we're going to need.
Okay, next question here. Can you speak to the research findings or anecdotally about the link between E200K and Parkinsonism?
So what I can describe, and I think I'm allowed to say it, so Nancy, actually, her brother was the first insight that I had personally in terms of the connection to Parkinsonism. I didn't know her brother, but we actually, based on his autopsy essentially, and being able, after he passed, to understand the connection. He didn't know it at the time, but he had 5D, and as we looked at other individuals, not me, but other individuals around the world, other individuals saw the same connection between what they call atypical Parkinsonism. As we've been looking at other people over time, as they've been growing up and aging, we've seen some earlier symptoms, mostly tremors in terms of what the first symptoms were. We don't have most people in the decade of their 40s, 50s, and 60s to be able to see later in life, so we're filling in the gaps. We're interpolating or kind of assuming that we know what happens in the middle, but we really don't. But what we are concerned about is, as I was saying, that this protein is necessary not just for the brain to develop, but for the brain to continue on and function appropriately, and that when it doesn't, and we could see this from Nancy's brother, that we lose brain cells over time. We do know that this is something that's necessary for the brain to continue working. It's not like it happens overnight. It's not like it falls off a cliff. It's not anything dramatic or immediate, so I do feel like we've got time for this, but on the other hand, I have a sense of urgency and optimism in the sense that our window of treatment is still open because this continues to be needed for continued function. We continue to need to be able to treat this. It's not as if the opportunity was only from up until 24 months of age. I think the window is going to be, up until, 56 years of age, or what it's going to be, but a long time.
Any additional? No? Good? Okay. All right, let's try this one. Is there any information about the age at which the seizures begin? Is it related to a hormonal change?
So the seizures in general are beginning earlier. We have had some cases in which we've had seizures during adolescence with puberty changes, or some things where they've been sort of needed fine-tuning again. So I do think, and this is not only with 5D or not only with these particular genes. I'd say it's a general thing that we sometimes see across other conditions, is that the body is going through a lot of changes in puberty and sort of readjusting. And with those hormonal changes, it's the second peak that we see in terms of seizures coming up again oftentimes. So it is another time to just be aware of what's going on. It is the case for most of your kiddos that the seizures, again, as I said, are something that we can get under control or your doctors can get under control, unlike there are some other conditions where it's just seizures all the time. And so, knock on wood, I'm not saying absolutely everyone in this room, but for most of you, the seizures are controllable with a single medication.
Now, is there a medication that you can recommend for getting kiddos more focus? Some doctors think that there's combinations that may not work, so is there any recommendation there?
I'd say in terms of things I've seen, just from what you've told us about, we've seen almost every medication used for attention. There was no clear winner in terms of what came out. So it's not as if all of you said Adderall is clearly a clear winner, everyone should be using only exclusively Adderall. Unfortunately, I don't think any of these is perfect. And so if there's something that seems to work better in terms of both attention and appetite and seems to sort of be the right fit, I'd say it's unfortunately based on trial and error. And I know that doesn't sound very satisfying or scientific, but that's kind of the way it's worked out.
Quick reminder for you, if you have questions to ask this panel, please start writing them down, either hold them up or send them to the end. We'll be coming along to collect them as we go too. On the way. Okay, next question here. Can the EEG and other data relating to our kids be sent to our home medical teams or to us to pass on?
So I think people are probably talking about the information from this meeting, if that's the idea. Just to say EEG data in particular, so if anyone was here in the previous days this week, to my knowledge, this hasn't happened. If anyone had something in terms of a new seizure that was not previously recognized, and again, that to my knowledge, this hasn't happened, we would have told you about that, or if we say that on analysis, we'll tell you about that. The EEG data that we collected is not really clinically useful EEG data. So we're not going to generate reports from you. We're not going to, if for some reason your clinician wanted it, I would give it to them. It's not a matter of that, but it's not clinically useful EEG data. As you'll recall, it was very brief. It wasn't long enough to be able to consistently capture seizures and things like that. So I don't think it's going to be useful to your doctors. In terms of any of the physical therapy things that you saw, again, I'm happy to share, but I don't think it's going to end up being all that useful in terms of clinically. If there's something that your doctor can come up with why that's useful, I'm glad to share and give you the data. With some of the things that might be more neurological or neurocognitive assessments, let us know, send us an email. My email's not up there, or grab me afterwards. If there's something that's useful, glad to share it. But we weren't going to generate clinical reports or clinical recommendations or things like that from the research studies going forward.
But Wendy, is the expectation to publish the findings?
Oh, I'm sorry. I thought we were talking about individual
We are,
results.
but just as a...
In the aggregate, we'll do as we did last time, which is that we'll get all the data together and present it back to the community, both with an online measure to you all as well as a publication.
Joe is joining us now too. Joe, question here about the new name associated with Jordan syndrome.
So this is in some ways a simple answer. If you think about it, there are a variety of genetic conditions sort of associated with Jordan syndrome. Early on, when we started the work, I think it was Wendy and a couple other folks who said, we have to find a name, because when we talk about PPP2R5D, when you get the PPP out, people think we're talking about pee-pee. And so, sorry, Wendy, I'm using, I remember that. And so we went through this process of saying how can we develop or assign a name or term that's more easily used and more meaningful to us as parents and in our community, but to our families and communities at large. that's where we landed with that. As a few other genetic conditions became associated with it, for the scientific community, we needed to help create a name that would sort of be an umbrella name for all of the conditions. And so Jordan syndrome is still Jordan syndrome. It's a subset of this larger community, which has been assigned the name by a scientific group called, and I always mispronounce his first name, but Hauge Janssens, and Birley is one of our team members here. So think about it as an umbrella term that covers not just Jordan syndrome, but a variety of conditions. Jordan syndrome is a major subset of that, a very significant subset. But in order to capture an umbrella for everybody, the scientific community used this approach. We have kind of dealt with that in a way where it's basically Jordan syndrome is a subset of this Hauge-Janssen syndrome, or terminology, I guess, the umbrella term. So I think that's the easiest way to describe it, is it's just an umbrella term that includes all of the conditions associated with Jordan syndrome.
Hauge-Janssen's.
Carol, you want to help me? I mispronounced the first
and
name.
I probably will too, but it would be the HJS syndrome or Hauge-Janssen syndrome, and under that would be type 1, which is Jordan syndrome, PPP2R5D, and then you will have type 2, type 3, and type 4, which will be the 2CA, 2R1A, and 2R5C genes once that's published.
Okay, next question. How common is regression, such as verbal or motor, in kids with PPP2R5D? Does there appear to be an association with particular variants? Dr. Mirza, do you want to take that one?
Yeah, well, as far as I think from Wendy, there hasn't been any, so yeah, we haven't seen regression in this condition so far. And so basically, it's not a disorder that's common, unlike other conditions where we know that regression can occur and it's part of the natural history. This is not what the data shows so far, and I think Dr. Chung showed a lot of this morning as well. So it's not a condition typically associated with loss of developmental skills. Obviously, this is where it's really important, I think, that we get longitudinal data or long-term data. The more we want to, so we want to follow our kids for as long as possible, well into adulthood and beyond, right? Because that's really valuable information that tells us, more clearly what that natural, history looks like. But so far, I think the data has been quite reassuring in that regard, and that there's no developmental regression. So yeah.
Is there an existing device that the research team would like to start testing for data gathering, and how can we support that?
Good question. So even during this meeting, I think I've been evolving in my thinking about this. I don't know. I'm going to poll you guys, actually, because I've got to learn from you. So, and some of you we've asked this question before. So the idea is that we want to be able to collect information from home, and I'm wondering what the folks in your family would be willing to tolerate. And so you don't have to vote for this, but the question is going to be, could they do the following? Okay, so I'm going to give you some options. Number one is they would wear a ring on their finger that would be a way of capturing information. Some of you may be wearing one of these at the moment, but an electronic ring, essentially. So raise your hands if you think that your child, your family member would be able to keep that on and to be able to do that. Okay, and you can vote for it. Okay, great, hands down. You can vote for more than one of these. Okay. Next one, do you think the individual in your family could wear something like a wristband, so a Fitbit type of wristband, and keep it on? Okay. Yeah, so assume that we would ship you some sort of device, and we would help you set it up, and we would help you download data. Okay. The fake one. Oh, more than the fake. Okay, how many do you think, if there were something that were a sticky that would be on the arm, so not on the wrist, but some stuck on electronic device on the arm? Raise your hands if you think they would keep it on.
A little bit less, okay.
Okay.
And I disagree.
Next item, if they were sleeping, so at night, if they were sleeping, would they tolerate wearing something on their forehead, a headband type of thing on their forehead?
Yara would.
It's not a whole lot of,
Okay.
A lot of reality check.
I know, this is it. Okay, last one. And I think this, I won't tell you. Okay, last one. If we were to have an electronic mat that would be under the mattress, be able to tolerate that?
yeah, because they probably wouldn't have,
Assuming they stay in their beds.
Okay.
Yeah, there you go.
Okay, so that was an incredibly helpful experiment for me. Okay, so now we've just narrowed down the list of possibilities based on that. And now the question for any of you, how many of you do you think if we were to, I don't know if you've ever held one of these devices, but think that maybe with a little help you could figure out a way with coaching to be able to upload data to the cloud? For any of you? Yep. Okay, excellent. I think we have our answer then. So there are at least one or more ways that we might be able to do this, and don't worry, we'll have help for you if we end up doing this.
Okay, I think this one's pretty important, especially for our new families. Can we hear a brief genetics 101? And what do the other numbers besides PPP2R5D mean?
The other numbers, I'm assuming being the variant
I would imagine,
numbers,
yes.
yeah. Genetics 101. So as a geneticist, I can say...
No pressure.
No pressure, yeah. And I'm happy to, of course, if there's a lot that can go under this. I mean, this is why we have like an hour-long conversation, typically in clinic at the time when sometimes this surprising news happens, right? That, you know, your child suddenly gets this diagnosis, right? So typically, so PPP2R5D, it's a very, all the genes, pretty much we have, you know, thousands and thousands of genes, which are basically units of DNA that most of them, but not all of them, make proteins, which are the building blocks of our body. Gene names are quite an enigma, basically, but they get named for different reasons. And this one happens to be a very, you know, wordy kind of thing, right? So it's basically named because it's a phosphatase, which are basically a family of proteins that take phosphate groups away in the body. So they have this PPP kind of designation, and then it's followed by the exact type of molecule, which is why you have this combination of letters and numbers. I typically tell my families, don't worry if you can't remember the name of this gene. We'll walk through it, you know, we'll get to know it intimately over the next few years, you know, of basically learning about this condition and everything. But this is the name of the gene, which is quite, I know it's a little bit of a, you know, again, a mouthful. But typically for each gene, you get a set of like, it's almost like an address, right? You have different levels to a home address. You've got the city, you've got the street name, you've got the unit number or the house number. It's kind of a similar thing when it comes to deciphering the report. Because what you first see is typically like the DNA change at the DNA level. So, and our DNA has 4 letters, basically, that are repeated over and over. So you'll see, when you see like a C dot in the report, that tells you that it's at the level of the DNA, and you'll see exactly where that genetic change happened. And for most of the PPP2R5D, I'll choose that as an example, most of the genetic changes, it's like a misspelling of our DNA. One letter gets swapped for another. And so you'll see it says A, instead of an A, there's a C. So it's literally a swap. There is no loss of DNA, there's no gain of DNA, the DNA is all there, it's just one kind of letter gets swapped for another. So that's at the cDNA level. The last part that you'll see, which is a lot more relevant, because that was what was talked about a lot this morning by both Carol and Dr. Chung, is when people say E200K or E198K, what does that mean, right? That's at the protein level. So, and this is the most relevant part. When people say E200K, what does that mean? It means that at amino acid 200, number 200, of the whole chain of amino acids, you have one amino acid swapped for another. And the amino acids have a code. So E, which is a specific amino acid, gets swapped or exchanged for another amino acid. So that's what that means. 200 is the address. So if you follow the list of amino acids and you stop at 200, it's switched to another one in the body. But the whole protein is there. The protein is intact. It's just a switch that had occurred at that location. And the reason why this is really important, which is why I think you all have done a wonderful job with this, is by providing your genetic reports to the team, to the research team. It's really, really helpful to know what is the protein change, because not every genetic change in PPP2R5D is the same, and there's a lot of differences that we can see, and so it's really helpful to know what is the exact protein change. It really helps the research team study this better, and all the mouse model work and the cellular work and everything that's happening. This is invaluable kind of information. But the three kind of sets of codes, if you will, are the gene name, PPP2R5D is the most important. Then you have the DNA change, which is this, kind of first level of the address. And then the last one is the protein change, which is what's most relevant, I think, here from this morning, is the exact protein change. So that's my genetics 101. I'm sorry if it's a little too long, but.
I just want to share that we are working on creating a video that explains all that in simple terms. The intention was the first half of the year, but then conference happened, but we'll work on it the next half of the year, and then we'll make it available. So stay tuned.
And I'll just add, if it's ever helpful, if anybody ever needs, what I usually actually do, what we do in clinic is I'll sit with my family with the report, and actually, we go through, there's a table often in most, labs, they'll just have a table in there. We'll actually literally go through and talk about what that means, just kind of interpret each of those kind of fields, just so the family kind of knows, because the reports are long and they're very, unwieldy sometimes. It's like sitting and reading an essay, basically. So sometimes we'll do that. I'm more than happy to do it if anybody has questions about their child's report.
All right, next question. Are there any specific legislative or policy risks to the research, for instance, stem cell lines? And if so, how can we advocate?
So I'm not worried about any policy issues when it comes to stem cells. So we haven't, just so that everyone knows, we haven't done anything in terms of fetal research. We haven't taken any fetal samples. There's nothing at all that any of the research team have done like that. They've used a remarkable technology to take blood cells from some people and to reprogram them to make them pluripotential, but they haven't used any fetal tissues, or no fetuses have been used in any of this research. So I don't think I have no concerns about it. I don't think there are any ethical concerns or government concerns about any of that from any of the governments represented. What I'm trying to think of is, at least in this country, because I know the funding for this country more than others, I do think there are potential threats that are going to be coming forward, and I think there's a lot of talk and noise, and we'll see what happens in terms of NIH, the National Institutes of Health, which are the major federal funding agency in the United States, and the continued budget and dedication of resources to research. So I think that's a potential threat in the United States, at least. And then I would say from the pharmaceutical industry side of things, or biotech and pharma, they're just having I'm not saying they don't make money in terms of doing things, but I do see them pulling back from rare diseases. I see them investing more in terms of common conditions and less in rare conditions. So I do think in terms of filling some of that gap, it's important for us to think holistically about this and not assume that anyone on the pharmaceutical side themselves will do this. I think we can get them to partner with us, but I don't know that they would do it on their own. I think they look at the number of the audience for their conditions, for their therapies, and they're not inclined to go after if it's a rare condition right now.
Anything you want to add, Joe?
Anything to add, Joe? No. All right, how about this one? Is life expectancy different for any individual with Jordan syndrome?
So I'll say for the most part, I'm optimistic. So as we're looking forward in a good way, we're not, thankfully, seeing people that are dying suddenly, unexpectedly of complications like epilepsy. That's just not something we're seeing. We do have some evidence from the Parkinsonism, like I said, that if we think of a normal life expectancy to be in its 70s, that I think we are cut short, a little bit short of that. The thing I get concerned about for anyone with any sort of disabilities is that they may not be able to effectively advocate for themselves and communicate for themselves. And so, as an example, you can imagine for yourself, if you had appendicitis, you might be able to quickly go to an emergency room and say, I've got fever and I've got pain right here, doc, and you need to do something, and you can advocate for yourself. Anyone who's got difficulty in whatever way, who can't advocate for themselves, something like that, then we tend to delay diagnoses as a general rule. And that can be for a heart attack, that can be for diabetes, appendicitis, anything else. So I'll just say that you know your children, you know your family members best. You need to be their advocates for them in those cases. And so just trust your instincts in terms of when you know that something's off, it just doesn't feel quite right. Calling your doctor, talking to the person in the emergency room. We just trust you that you know when something's different, and you know better than we do. So, but we do need you to be their voices or amplify their voices for them.
Joe, we had another question too that we had touched on this earlier about the accessibility down the line. What does that look like? Because I know this has been really important to you to make sure it was accessible to all.
Yeah, I think when we started and had our first family conference, I can't believe it's been that long ago, we knew, and Wendy and the rest of the team had sort of coached Carol and I to know that this is a key thing, that it's great to find help for our children, but then we have an obligation to make sure that that help is accessible, both in terms of location, geography, but also in terms of cost or price. So we've embarked on that with that goal in mind since we started, and we had good advice, and thank you for the research team and everyone who we've set up a system that allowed the foundation to have the licensing rights for the intellectual property coming out of the research. That's helped us. The other thing, quite frankly, that's helped us is that we're, through all of your help and the help of others, we have been able to provide significant funding now for the trials, for example. Carol and I, with Wendy's help, have had a couple of conversations with Tara, the pharmaceutical company that we're partnering with for the first trial. And we've talked about how important accessibility is. Not only here in the U.S., but in the entire world. And we have talked about a plan to help them, assuming we get really good results, which we're optimistic and we're hopeful. And we are continuing that discussion. It's a difficult one. It's a different one. But like so many of the conversations we've had on this journey, people say, well, gee, it's never been done that way before. And we sort of say, well, that may be okay, but why not? Why not? Why don't we look at what our overall goal is? And so we're looking at that. We're very, very focused on that. Carol, I think we'll be having another discussion soon. But our goal is to make sure not only that we hit the goal line, but then when we get to the goal line, we've done it in a way that will make it so that it's accessible for all of us, all of our families, not just location, but make sure that it's reasonably priced. And that involves a lot of things. It involves negotiating with the pharmaceutical companies, it involves negotiating with insurers and government-run programs, and just know we have that very, very much on our radar screen. Wendy's right. I'm kind of like a broken record on that, but I recognize and I hear it, and I know as a parent and looking at all your faces that at the end of the day, that's very important, and we're on it. Is that a fair answer? Yeah. Don't have a specific, don't have it solved totally yet, but we're getting there.
Yeah, definitely not an afterthought. It's
Yeah.
been forefront from day one.
Okay, next question here. Has AI helped expedite the research? And if so, how can they help to support in that path forward?
So I actually will also look to any of my colleagues on the research team, but I'll tell you the way I think of this. So in general, for research and other things as well, but especially for research, we're absolutely using AI and machine learning to be able to think about large data sets and large language models, to think about assays, and as you screen through, whether it's compounds, whether it's guides, whether it's ASOs, any of those things, if you have enough data and enough outcomes to know what works and what's not working, you can start to do the pattern recognition, and you can start to do more intelligent design as you think about those different tools that we're now using in terms of thinking about therapies. The issue becomes, do you have enough data to learn from? And so what I would say in general, and this is not just true for our condition, it's much more important that there's data access and open data science in a much, much larger way than just our community. And so if you think about drug design in general, if you think about ASO development in general, if you think about guides in general, we're all going to get smarter faster, and especially across the rare disease community if we have open access to data. So I think we as scientists are advocating for that. Certainly it's a requirement in terms of federal funding. It's a very big part of NIH now for any NIH-funded programs, that there is data access and a lot of detail in terms of how to make the data findable, usable, other things. A limitation, which I understand, but it still is a limitation, is most of this work is done on the industry side rather than on the academic or university side. And for many of them, that's their entire business model in terms of doing this. And so there are some data silos and data access that not everyone sees, but I think increasingly we're all trying to make sure that data is more accessible so we can learn faster. And if any of you know how to do this, we'll be glad to take some help.
I'll just actually tag on to that as well. So I think especially in the drug repurposing area specifically, there has been a lot of interest and momentum in terms of using AI-based tools, because the whole premise of it is that, it's rather than each time developing a new drug from scratch, which takes, a lot of resources and a lot of time. There's a whole field, of course, now of just repurposing existing drugs for neurodevelopmental disorders, and that really relies on exactly what Dr. Chung mentioned, is of all the battery of drugs, as long as you have data accessible, you can look for commonalities across disorders and actually repurpose some of the drugs across as many conditions as possible, which in theory could be a lot more successful than, again, each time creating a molecule or a drug from scratch, which takes a lot more work. So AI is definitely, I think, very big, and we have been really kind of we've been hearing a lot about it, especially in the drug repurposing kind of field.
What would be the most effective way to educate other medical professionals about Jordan syndrome?
So I think, I don't know, maybe I'm naive. I think most of your doctors that are working with you are probably good people, and there's only so much, I hear a laugh here, but anyway, maybe I'm naive, but anyway. But none of us can know everything is the limitation, and this condition wasn't even known for most of your doctors when they went to medical school or nursing school or dental school or whatever it was, so I can't fault them for that. And your child is probably the only patient they will ever meet that has this condition that they know of, and so that's a hard thing. What I said that we've done, and Lexi, I don't know where Lexi is. There's Lexi. So, what Lexi and I have been trying to do is to be able to make the information that we know about Jordan syndrome, and we'll continue doing this also for other conditions under the Jordan syndrome umbrella, but to make the information, number one, freely accessible, to empower you all with that information so you can take it forward to your doctors. And as I said, the next portion of this is just to make it on the information superhighway where they can't miss it. It hits them in the face. As long as your child is correctly coded and in the electronic medical record so that it'll just automatically pop out. So we're trying to build this system across rare diseases where it doesn't become infinitely challenging to dig and find the appropriate data. It's more a passive process. And as long as they can follow the rule, essentially I think of it as the manual of operation, right? As long as you have the manual of operation for your child in an age-appropriate way, they just are given that information and they trust us collectively to know that this is trustworthy information that they should use because it is evidence-based, your evidence upon which it's based, then hopefully they will follow that information and insurance companies will pay for the costs associated with that. That's the strategy that we're trying to do this. I'm, again, maybe overly optimistic that this will work in terms of what the process should be, but I think otherwise you have to, until we get that completely done, you should be going with the information from, and I don't know that, do we have them on the web?
They're all on the Resource Center.
So in the Resource Center, you should download a copy of that, take that with you to your doctor's offices, laminate it, whatever you need to do, but empower them to work for you and take that information with you.
And Carol, I think this one to you are efforts being made to identify older individuals with Jordan syndrome.
It's a little harder than we anticipated to connect with older families, but we do reach out to other bigger symptoms that we're part of, like autism, epilepsy, Parkinson's, and we establish partnerships and relationships, and we tell them about the syndrome and say, hey, your people might be our people, and we provide them with information, and they're all been very willing to kind of share them within their platforms and try to find individuals that way. Anything else from your end on finding older individuals?
I do agree. This is a challenge, to be honest, across most genetic conditions that I've seen and we've worked on, and it's multifactorial. It's not lack of willingness of people or families to share, or lack of, or even providers of also sharing information. I think the biggest factor, from my experience at least, is that accessibility of genetic testing. So for many of the families, maybe in this room, I think most of the children were diagnosed with something called exome sequencing, maybe, or maybe now genome sequencing is coming around as well, which is an even broader test. These tests were not around, decades ago. So people, and also insurance, unfortunately, at least here in the U.S., insurance coverage for genetic testing in adults is extremely hard. And there are fewer genetics providers who see adults. So it's multifactorial. It's a bit of a complex thing, but I totally agree. I think one of the key things that could help facilitate is for example, we will reach out to we have an adult genetics group at the University of Washington. I'm based at Seattle Children's, they're based at the University of Washington. We have a very close relationship with them, so, setting up these partnerships and collaborations with, providers, at least on the provider side, is something we try to do. But on the family side, I think, it's really spreading the word, I think, and spreading awareness as much as possible. For example, we're working on a condition where, through connections with providers, we got to be aware. Somebody had done a study in Germany, actually, of offering genetic testing on individuals who were in a nursing home, basically. So they were all, really old, older people. And we found a new person who just got diagnosed at the age of 78 with this genetic disorder. So, so people, I think that the community is starting to do genetic testing on adults a lot more. So I think that's going to certainly help. But it's a huge challenge. I won't lie. I do think it's a huge challenge. I think there's probably less accessibility of testing in part as part of this. I don't know, Wendy, if you wanted to add anything.
Yeah, so I guess I've thought about this in the following way. So I always, just those of you who know me will know that I ask the question, what's in it for me, all the time, right? In terms of what motivates anyone to do anything, I just ask the question from their perspective, what's in it for them? So the challenge for older individuals, say, for instance, over the age of 50, is their payers ask the question, what's in it for them? Why should I bother making this diagnosis? What's going to change in terms of the way I'm going to medically manage those individuals? And the answer is, right now, I can't defend that. I don't have a good justification for what's going to change because I just don't know. That, frankly, I don't know until I start doing this. So I do think the answer to how we get there is going to be based on research initially. I don't know that we can put that burden on the healthcare system where it's your taxpayer dollars, by the way, in terms of that for those of you in the US. And so I don't have a good justification for doing that, which then puts it into, we're still discovering. We don't understand. We don't know the answer to the question, what's in it for them, but there may be something. So within this, we've tried to do, and I mentioned Spark at some point. This is an autism. We mentioned, or Carol mentioned autism. I've tried to think about other studies that we can use, and so Spark, although it's largely unrelated for this community, anyone who has an autism diagnosis in the United States, we have a mechanism for getting free genetic testing, which will answer some of these questions, but it only works for that carve-out of individuals with autism. And so I don't have a ubiquitous way yet for doing this, except there were studies like All of Us in the All of Us program, but they weren't really designed for individuals who don't have capacity or may not be able to consent for themselves. And so I don't really have the perfect research study for this. I did try and I mentioned this once before, but I'll just say this, and we can certainly find the article and distribute it in case you can think about how to use it in your communities. I worked with a reporter who had a family member, and she wrote the story, but I helped her with the content for it in The Atlantic. So we tried to put this in a mainstream media source in which, in their particular case, an older family member had always had an issue, a neurodevelopmental issue, but no one ever knew what it was. No one knew the name of it. No one had any idea what it was. And in fact, when we started the story, I didn't even know if there was going to be a genetic name to this, if it would have a gene, but we went through the process, and she tells her story in this Atlantic Journal article about how we went through the process, what it's meant to her family, all the rest of these things. And I do think from the family point of view, having a name, having closure, having a community, which you all know so well, it does have meaning. I don't know that an insurance company will pay for it, but I think it does have meaning, and it certainly advances our understanding of these conditions. And since then, I've had more adults come to me, usually they're family members who are wanting to answer this why question. And so we've continued to do genetic testing on more and more people. I'd say it's been incredibly helpful for me in those conditions to understand the science of it, because we have understood in some cases, and I want to reassure you, we have understood in some cases that there's a cancer risk associated with some conditions, not this condition. Let me emphasize again, not this condition, but with other neurogenetic conditions. There are some things that are very specific, a certain cancer risk, a certain rare condition risk, sometimes certain other neurological things that happen later in life. And so you become more empowered to be able to answer that insurance question, ultimately, why? Who cares? What's in it for me? You gather the evidence to do that. But I think there's almost a grassroots effort that we've got to do in terms of other family members who want answers to that why question. And I guess my only little hope is that the cost of sequencing is coming down, that research studies will be able to afford to do some of this research that'll help answer these questions. But it's a gap we have not yet filled, and it's challenging because no one rare disease group really can fill it. It's almost got to be a collective effort to do it.
I want to piggyback off of what you're just saying there, Wendy, too, because we just got a question in about 2R5C and links to leukemia. Can you speak to that at all?
So we can take this offline. I may not be aware, and Verly, I don't know if you want to say anything. I'm not aware
We can save that for the next small discussion, too. Verly, I'll make sure you get this, and we can talk about it then, too. Okay, how about this one? If a child had a normal EEG in infancy, is it necessary to retest as a teen or a young adult?
I think it depends on what the concern is, right? Because basically, and I usually kind of, there's a mantra that my friends in neurology say all the time, is that we're treating the child, not an EEG, right? So if there's a clinical suspicion of seizures or some other neurological, dysfunction or abnormality that warrants an EEG at any point in time throughout a person's life, then absolutely it should be repeated, because it's not like a static thing. So if a child is having some abnormal activity and it's suspicious for seizures, and they have an EEG during infancy and it's normal, that doesn't mean that it's not going to change over time, or that things might manifest later on, right? So I typically kind of will kind of probe a little bit here and kind of see all right, what is the specific concern? What is the child showing? What kind of movements, or if it's seizure-like activity, what do they really look like? I will say one of the most valuable things that I've learned throughout the years is that families' reports and family recording, like if they're actually just, even if they're just writing an observation of what they're seeing, and sometimes if they even show us like a quick video, if they're able at all, which I know it's a scary moment whenever you see your child doing something different, but those are extremely valuable in terms of determining, all right, let's do an EEG, and sometimes it's a short one, sometimes it has to be a longer one. So I think the short answer is like it can change over time. So certainly if something is concerning, for most common it's usually a seizure-like activity, even if an earlier EEG was normal, absolutely I would say bring it up to whether you're doctor or neurologist. Even better would be a neurologist if you have a neurologist on board, and a repeat EEG could always be done because again it's not a static thing. Many children have had multiple EEGs over time, sometimes just to work them up to see like, all right, what is it exactly that's happening? Is it a true seizure or not? So a lot of kids might have more than one EEG, which is not fun, but it might be needed. So yeah, so I think it could be repeated at any point if there's a concern, but it depends on the concern and what you're observing.
What portion of known families have provided data to Simon's Searchlight, and how can we increase it, and why is it important to increase that?
So I'm going by the numbers that Carol gave this morning and the numbers I gave this morning. The rough estimate, about 50% of who are known worldwide so far in Simon's Searchlight. I actually think that's incredible. It's not every last person, obviously, so I think that's what Carol does, is kick us all in the butt as we're going forward. But within this, like I said, not everyone has access in terms of digital data. We have problems still in Searchlight that we can't do every single language, so we're working very hard. Actually, we were just doing it out here during the lunch break, working very hard to add languages to be able to do this so we don't leave anyone behind. But I think we're doing pretty well.
We can do better, though.
And I think we do want to talk about doing better and why. I always run into this when I'm doing my late night research work, is that if you, from the outside world, the scientific world, they'll see certain number of cases published. And that tracks a little closer with the Simon Searchlight, so that 50%. We know, because providers around the world and families have gotten in touch with us, that the numbers are significantly higher. It's important for everybody to know, it's important for the drug companies that we're talking with to know that, while this is still a rare disease, the audience is bigger than what they might see that's published in a paper somewhere. That's why it becomes really important. So y'all can help us with that, right? The more we push those numbers up, the more people will pay attention.
Is it a common issue that children with the condition are immune to medication?
So I guess I'll reinterpret the question a little bit. I think what the person asking the question is asking is maybe they're not responding to the medication in the typical way that most other children do. And I think the medications is a big, broad category, and so I do think they respond to antibiotics the way other people do. I don't think it's always like that. I think in terms of something like ADHD medications, as an example, they may not get the full response that we hope they do in terms of other people that are taking Adderall or things like that. So I don't know that they're immune, but their brains are definitely wired differently and they're working differently, and so the medications, unfortunately, aren't as effective for the symptoms as we would like them to be. But some medications still work. So I go back to the epilepsy medication. The epilepsy medications still work, and so it's not like all medications or even all brain medications that aren't working.
Are 1A and 5C more rare, or are they not getting flagged as significant as families receive this gene variant? And are they grouped with 5D in panels across the world showing their significance?
Well, so we're lucky to have one of the world experts over there on 1A and 5C. So I'm going to just hand wavy here at the moment, but Verla can please disagree with me. I mean, my personal interpretation of the data so far in terms of the numbers shown this morning by Carol and Wendy is that so far the genetic data is showing that R5D is more common than 1A and 5C, right? If you just look at the existing numbers, whether published or in the Simon's data set. In the U.S., I think, and please, I'm actually interested in kind of querying the families in terms of the way their children were diagnosed. But in the U.S., I think now, most often, the diagnosis is made after what's a very broad genetic testing, what's called exome sequencing, which looks at most of the protein-making genes in the body. Maybe there's a fewer number of families who got diagnosed through what we call a panel of genes. So like the lab would have like these custom-made panels that they would, kind of advertise for. And so some of these panels offer like lower cost, which is why providers sometimes opted for those panels a few years ago. They're kind of fading, to be honest, quickly, because the cost of sequencing, as Dr. Chong mentioned, is coming down. So it's becoming they're becoming obsolete a little bit with time. So it depends on the panel. If your child was diagnosed with a panel, maybe it included 5D, but it didn't include 1A and 5C because they weren't known or something, So, and the way that these panels get designed is when a gene is published, it can make its way on a panel if it's like more common. So there's like this bias, this constant bias, right? Is that things don't get added onto these panels unless they're published. But if you don't offer the testing, they're not going to get published. So it's a bit of a feedback loop. But for the most part, if your child was diagnosed by exome sequencing, let's say, R1A, 5C are all, these 3 genes and others are included. I think one of the key things that might contribute to the lower numbers for 1A and 5C, and which is something we kind of chatted about today as well, is that if your child's variant is unique to them, so if they're the first child seen by the lab, most importantly by the lab, who's looking at the data, and there's not a lot of like functional data out there for that variant or for that change, oftentimes they get this label of a variant, what we call a VUS, a variant of uncertain significance. What VUS means in general terms is a gray zone result. It means we don't know if this is really the cause or not. We just see this genetic change. It's unclear whether it really does anything. VUSs are a bit of an issue in the genetics world because it doesn't give a definitive diagnosis for those families, right? It's a marker, and any of us could carry a marker in something. So I don't know, maybe some of these, there's a number of families out there with R1A and R5C who have more variants of more VUSs than clearly bad genetic changes that give them the diagnosis in a more clear way. I think that might be the possibility, and that's certainly something we see across other genes when there's just not enough people out there with it yet, not enough data, is that there could be a number of children who will have, these kind of gray zone results, and so they don't get formally diagnosed. But then with time, as functional data comes out, as people publish series, where they publish new families as they are getting diagnosed, then it could provide clarity. So I think that's kind of my hand-wavy answer to this a little bit. But yeah.
And I just want to add one thing too. So what we did a few years ago with 2R5D is we reached out to all the major labs that do the testing in the US, and we kind of advocated to make sure that 2R5D is on the main panels when it comes to things like epilepsy, autism, and others. And when the 2R1A publication came out, we did the same thing. So as soon as the 2R5C publication is out, we'll be doing another round and making sure that all 3 of these genes, at least in the major labs in the US, will be on all the panels that we think they're relevant to what we need them to test for.
Why were outliers on Vineland removed? Was it conflicting or seemingly unreliable data?
So I don't think any outliers on the Vineland were removed. Every person was plotted on there. The only thing that wasn't, as Rita was saying that, it just spurred for me. On the data that I presented to you this morning, I did not include variants of uncertain significance, just for full disclaimer on things. I tried to make the data based on things we were certain about, and so any of the data, and that'll be true of anything we post, and you can leave the little sort of asterisks below. If you don't see your particular variant represented on that, it's because it may be one of those that we're not 100% certain of, and I didn't want to potentially bias the results. But otherwise, all the data are shown there. No data censoring.
Is there a chance for people overseas to join the trial but work with their doctors who report data over to you instead of face-to-face and just do video link chats?
Unfortunately, the answer is no. So there are, when you're doing a trial for FDA registration, they're very strict, and the company, because it's their, they're the ones ultimately responsible for this, are being very strict about this. So we will need to, and this is true in the United States as well, you will need to come to one of the 3 clinical sites that we described. We've tried to make it as accessible as possible, but as I said, I know it's difficult in terms of the travel and the multiple trips. And we're, over time, I think, trying to explore with some of the measures I told you about with digital data collection from home, how can we do more home-based collection over time? But this is our first, as I think Carol and others have alluded to. One of, I think there are going to be others in the future that we'll get better at over time. But for this one, we're going to have to come to the sites.
And to piggyback off of that one too, can Canadian families participate in the clinical trials?
So from my point of view, especially when we're talking about North America, and we need to check with Tetra. I was thinking about this when I said this morning. There is something about taking it across the international boundary that I need to check and see if there's any problem with that. Otherwise, from the logistical point of view, and I say this because Vancouver is very close to Seattle, I can imagine if we don't have a problem with something crossing international lines, that logistics could be okay. I mean,
If they're English speaking.
English speaking, I'm sorry, yes.
Do you know of any antidepressant, anti-anxiety medication that doesn't interfere with epilepsy medications?
That's a very challenging question, actually, because there's so. That's a bit of a tricky one, I think, because there's a lot of anti-seizure medications who have different interactions and a lot of different antidepressants and anti-anxiety medications. So I would say that would be, that's like a customized conversation to have depending on the specific drugs. There's just too many of them. I don't know, Wendy, if there's a more, specific way to address that, because there's just too many anti-seizure medications with very different profiles, and same for antidepressants. So yeah, and typically if a child, I'll just add, if your child or any child is on multiple drugs like that with different classes of drugs, most often your neurologist will have to talk to the psychiatrist, people will have to talk to each other to make sure that they work well together. So it's not something I would want you to have the burden of worrying about. It's definitely something that your team, your care team, should put their brains together and sit with you and go through and make sure that any new drug that's added works well with everything else that's on board. Right, so I wouldn't want you to carry that burden alone, but yeah, that we would have to look at all the different kind of drugs that are on board already. Yeah.
Are there drugs that should be tried to limit the tremors and/or atypical Parkinson's symptoms?
So if you do find that your child has those symptoms, I think the first thing is how bothersome the tremors are. In certain cases, I think they're probably, if they're not bothering your child, if they're not bothering you, don't overly medicate, I guess is one of the things I would say. Things get complicated due to drug-drug interactions and other things. Otherwise, when you start talking with your doctors, the same, and we know this really from Nancy's brother, the same medications that are useful for Parkinsonism are also useful for this, and so we can have offline conversations, but they should think about it from the Parkinsonian point of view and the dopaminergic system.
Another question about this. In case of an early Parkinson appears, or Parkinson's appears early, is it treatable with any kind of medication?
Yes. So bottom line is yes. In the same way that we treat symptoms for Parkinsonism, they seem to respond to those medications.
The children of our children, if our children will have treatment in the next few years, will still have 50% chance to be born with the mutation of PPP2R5D?
Yes, for the most part, so far, from what we know about the genetics, it's a 50%, what we call a 50% recurrence risk, which I'll just quickly also mention. We talk about it, when we say 50%, we mean it in a statistical way, which means if you toss a coin twice, right, it's 1 in 2 chance. So it's not like, so that's just the general way. So it's possible to have multiple children, because each of them is a different pregnancy, right, that are either healthy, or multiple children that are affected depending on that coin toss. So, but yeah, it is a 50% chance recurrence risk.
And let's also take this one here. What are the chances of a sibling also having the PPP diagnosis?
Yeah, I'll just add real quickly, and maybe Dr. Chung can add to this. So for the most part, the data shows is that most of the genetic changes are what we call de novo, which means brand new. mutation. And what that typically means is that mom and dad would have been tested or included in the testing of the child and shown to not have the genetic change. So in that case, the chance of having another sibling affected for your child is extremely low. We never say 0% chance, unfortunately, because none of us can ever say that we are at the 0% chance of not having something happen to us, like that. So no pregnancy has a 0% chance, unfortunately, as human biology goes, of not having a genetic mutation. But it's extremely, extremely low, right? It's as low as we would hope, There are exceptions to that, which I think there has been observations of, there could be a parent who has the condition, like the previous question, is that, a parent could have the condition and pass it on, and it's a 50% chance, so that means there are multiple affected children in that situation. And there's another extremely rare situation, which we were also chatting about today, which I don't think, as far as I know, has been observed, is that sometimes a parent gets tested, both parents get tested and they're negative, but the test is really taking like a blood sample from the parent, or sometimes a saliva sample from the parent. There are extremely rare situations in genetics where a parent could have the genetic mutation hidden in their gonads. So that would be, eggs in mothers or sperm cells in the fathers, one or the other, and what that means is that in theory, if they have this genetic change hidden, they could pass it on with future pregnancies. That in general is extremely low chance. There are other genetic conditions where we've seen that happen, so we kind of counsel families that, we have a higher suspicion of this happening. I don't think it's been observed with, as far as we know, I think, with any of the, the PPP disorders. But that's a very rare situation. What's that?
Verla says yes.
Verla says yes. You've seen it? Oh, is that the one? The one family. And it's 5. What was it, Verla? Sorry, was it 1A or 5C? 5D? Okay, so Dr. Jensen's here is saying that there is actually one family potentially where this has happened in R5D. But keep in mind, we're talking about more than 100 families, so far. So it's extremely rare. But for most families in this room and everywhere else in the world, the chance of having a sibling affected is very, very low. And if families are worried, what I also usually tell them is that once the genetic change in your child is found, by the way, at least in most big centers in the U.S., prenatal testing, whether you want to do it before, during pregnancy, or even sometimes pre-conception, is something you could think about and have a conversation with a prenatal counselor about if you really, really wanted to make sure, that any future pregnancies are unaffected. So there are options for testing.
Is there any information that you can share about gene therapy for the condition?
So I'll just say it is an active and very important area of research for the group. So the scientists here spent a lot of time earlier this week. There are multiple strategies in terms of doing this. Kyle, I think, is happy to talk with other people if you haven't seen them at the poster, but thinking about strategies for base editing or gene editing or prime editing to be able to make corrections to this. I think long-term, as we think about this offers incredible opportunities. I think there's a lot of work to do still to be able to do this across the brain, to be able to deliver it in a safe and effective way, to make sure there are not what we call off-target effects, or to have bystanders of potentially misfiring and hitting other genes that you didn't intend to treat. But it's a very exciting area, and for one of the strategies that Kyle and his team are looking at, something called prime editing, the first, what is called IND, has been issued by the FDA, investigational new drug, to use this for a completely separate condition, and it has a lot of differences. So, but it is now going into clinical trials in the United States, in terms of another disease called chronic granulomatous disease. So we shall see. We're going to learn from each other in the rare disease space, and I think that's what Carol and Joe have been talking about. It's multiple shots on goal, it's multiple strategies, it's thinking about short-term and longer-term solutions. So the team has incredible depth on the bench to be able to think about plan A, plan C, D, E, F, all the way to Z, in terms of trying to make sure that we've got multiple strategies.
Are there different levels within our children of intellectual disability, or can it vary depending on their variant?
So it went by really quickly, and I didn't do a good job of explaining it, but on a lot of the graphs I was showing, we call them violin plots, but there are distributions about everything from on the Vineland score, if one thinks of that as a scale of what we call adaptive development, even within one specific genetic variant, not everyone is the same. There's still a distribution and a range in terms of that. I've been racking my brain to understand what are the reasons for those differences. Why can someone with 5D and E198K within that one particular genetic variant that's all the same in that group, and we have a lot of you, we still see quite a range with some people in the normal range, some people in the disabled range, some people in the profoundly disabled range, and I don't know the answer yet. I'd be curious if any of you all have some insights into what you think the answers are. There could be other contributing genetic factors. There could be other differences by country. There could be other, what I think of as cohort differences based on the age of the person and sort of what was available to them at the time they grew up. It could be early interventions. It could be whether or not they had seizures and how well the seizures were treated. I've got lots of ideas in my head, but really no answer. But within these are some of the questions we're asking and trying to answer, because if there's something that's worked for one of you, even if it's just one of you, if one of you holds the secret sauce inside, we want to be able to unlock that for other people. And there are some of you that, again, you're doing within this distribution, there's some folks doing differently than others, and understand what's accountable for those differences is important.
Is there a standard or a recommendation on school services or education in general? Are there resources to educate school systems?
So I don't think we've gotten to that level of specificity. Lexi doesn't know this, but this is what we have down the road in terms of what to do. And my guess is some of you are educators in this room, maybe even special educators to help in areas that I'm not expert in. I do think in general, I don't know that there's one size fits all. There's a lot of repetition. There's a lot of patience, a lot of repetition. My own observation, just watching some of your children, is that they're understanding more than they can express in many cases, and being able to figure out ways that they can express that are different, I think is a portion of this. And so I'd love to have insights from what you all have learned in terms of being able to unlock that potential. But I feel like I've learned over my career of the last 30 years, and I feel like I'm kicking myself afterwards for people who had a lot more potential than I realized at the beginning, and I want to make sure we unlock that potential. But I think in terms of this, and I will say, advocating for health insurance, and that's a little tiny thing compared to what it is to advocate from the educational point of view. It's a lot more resources, and so I think we're going to have the ammunition to go behind that, the evidence to go behind that.
Yeah, and just to share, what we've learned within our community throughout the years is some of our children do really well in a just general education mainstream setting with the right supports, while others do better in more specialized kind of schools, also with the right support. So I guess what I'm saying is whatever setting you end up with, you want to make sure they're getting the right support and really push to reach their potential. And that's a lot of time, a lot higher than what we expect from our children. So just push yourself and your educators to expect more, and provide the right supports in whatever setting you think is best for them, and they'll be better off for it.
You want to add to that, Joe? Yes.
So I haven't gone through this myself as well. At least here in the U.S., generally speaking, children with special needs are required to have what's called an individual education plan. And that plan should include recommendations on various therapies and support for the children. So advocate for your children, but know that there should be that plan, and that plan should detail the specific additional resources that your child needs that should be provided by your school district.
Yeah, and if you need anything to support whatever it is you're pushing for, call me. I've been on so many of our IEP meetings, and whatever you want to push for will help you, will provide you the evidence and the support so you can get exactly what you need for your child.
Okay, what exactly are you hoping to measure with the devices that we voted on?
Fair point.
Okay, you asked for it, now I'm going to ask you. Okay, so here's the hypothesis, or here are hypotheses, and I want feedback from you guys in the audience. How many people wish we could improve sleep in some way?
Here's one measurement.
That's what that's a large part of what I'd like to be able to measure. Sleep is an issue. How many of you are have concerns about anxiety? That's another thing I'd like to be able to have a measure about. How many of you are concerned about communication, verbal communication? I didn't get into it, but we've thought about wearable devices to be able to monitor in terms of expressive language and verbal output, and then look at the complexity of that language and be able to have an output of that as an outcome measure. What did I not ask about that you think we could measure with any of those devices? Temperature. Okay, we're overheating. Okay? So there are some things that have to do with the sympathetic nervous system that I've wondered about that you can get from heart rate and heart rate variability that may be an output of things related to temperature. So, yep. Excellent. Okay, so what I was hearing is hypotonia and movement, and so we've thought about with that, we call it actigraphy, but movement in general, so to understand how people are moving, how much they're moving, how rapidly they're moving, so factors like that, there are ways to be able to measure.
Marley's mom.
How about
Seizures while they're sleeping.
seizures? Okay, seizures while they're sleeping. So we've thought about that, but now I'm going to do the reality check. You told me that wearing a headband was not going to be so feasible. So there are some ways that people are working about with some of these sensors to be able to get seizures, even potentially indicators of when a seizure might be coming. They get increasingly sophisticated. So to do that, we might have to take a special one of the version of devices that I'm talking about, but good to know. Myoclonic jerking. So again, either from here in terms of doing it or the jerking movements, yes.
Okay. Oh, two more. Yes.
Pain.
Pain. Where in terms of the pain? Okay, I can think of a way of doing pain, but you'd have to work with us. So what I mean by that is that if you can get a sense of when there's pain, there are ways of doing things where, for instance, you might talk into Alexa or to your phone and being able to just annotate and say pain, and we would timestamp it and then look at the time, what's going on in terms of heart rate at the time. If heart rate is going up as we're feeling pain, there might be ways of being able to, with enough data, be able to interpolate that. That's a trickier one, though, and it takes more work to be able to look at.
Wendy, I'm going to throw one more out there. This is one that we're experiencing with Jordan right now, which is the Parkinsonian type tremors. Intuitively, we can see in Jordan that if she is more emotionally, what's the right word, overstimulated, whatever, or emotionally not happy, the tremors seem to increase. I don't know if it's worth measuring that, but it's something, and it could be just in motor movement, but I thought I'd throw that out there.
Yeah, so a couple different things. So with enough sensors, you can measure different parts of the body moving in all different ways. So depending on, and we have to be reasonable, we're not going to put 20 devices on people, but in terms of doing this, yes, it can be measured. Question came up in terms of heart rate variability. There are a lot of reasons why the heart rate can change, is the point. So it could be with pain, it could be with seizures, it could be because you're running down the street. There are lots of things to do it. So you end up having to put multiple pieces of data together to be able to understand and do an interpretation of what's going on, and you're not always right. But if you have enough data and you're looking at trends over time, and so you're comparing yourself to yourself over time, sometimes you can be able to disentangulate this. So a lot of, I know it sounded like mumbo jumbo, but there are ways of being able to come up with approximations to this, but we have to measure things that are important to you, and that's why I'm asking the questions.
Okay, Joe, this question's for you. Can we assume we'll always have the necessary funds to sustain the research and future potential medications? No pressure.
There's a joke
Wow,
for that.
okay.
Sorry, Joe, you know?
I would answer this in a couple different ways. One, know that our team, our research team, and a lot of you families out there have all helped to help make sure that's the case. You know, didn't say it a few minutes earlier, but one of the things I think that is helpful for us in that accessibility issue is that we're providing, it looks like now, about 85% of the funding for the clinical trials. Normally, that's a responsibility of the pharmaceutical company, and that's part of their expenses that they need to recover in the cost. We're doing that for a reason, right? To help us make a strong case that the cost at the end of the day of this successful medication is not going to be unreasonable. To do that, obviously, we have to be able to provide that funding. Now, we are being very careful. We have still a significant chunk of funding available that we're planning and keeping in reserve for not only these trials, but other trials. And in the meantime, we are continuing what we call the basic bench lab research that all the team is doing that's going to help answer more of the questions as we move down this path towards additional trials. Yeah, okay, I'll say it. It's my obligation, my responsibility to make sure that that funding happens. But I can't do it alone. Candace, you've taken on the role of being responsible for helping lead the fundraising efforts. Carol, we talk about it all the time. We will continue to do our job, and I can make that commitment to you. But we need you all to help. And it's not, we don't expect people to be able to, take on all that responsibility every day that we do. But there are simple and little things that you all can do to help us. And we're going to talk about that a lot tomorrow. So I don't think we'll go into a lot of detail today. But they're really small things, but we have big numbers. And so because we have big numbers, small things add up very quickly and become very important. And, we are a community together. We're not going to desert you all. We're here for the long haul, but we do need help.
Now we're getting close, guys.
Can I just make one brief
Yes.
comment? So I don't think many of you appreciate what you have in Joe. And I'll just say this because, like I said, I see a whole spectrum of people in the rare disease space. Part of what has made you so special and so effective is both Joe and Carol. But Joe has done a tremendous amount in a very unique way, I will say, in terms of being able to advocate for this community, truly in a way I've never seen anyone else be able to do it. And that has really carried the day in terms of being able to get things done. Candace and others have done a tremendous amount in terms of more what I'll call traditional fundraising, and it's been incredible to do. But Joe has really taken it to a whole nother level in terms of being able to get that done. So I just think we should acknowledge Joe for what he's done.
Thank you very much. It's not that I don't appreciate that, but I'll tell you what's really interesting to me. When Wendy said, this is what it's going to take, and at that time it was $20 million, which was a pretty good guess at the beginning. Since then, we've actually raised about 35 because we have bigger goals in mind, and we have more things that we're going to do. We are, and we'll give a complete report to this, we are reserving a lot of that funding for future things, additional things that will help our children. But because it's all so expensive, it is really important that we need your help. But thank you. I mean, I didn't know how to do this at first. I had an idea, and we've been blessed, quite frankly. The state of California stepped in and did a very substantial amount. Other folks are asking now several times today, how can we get some of our states to help? And we'll help you with that, right? It takes advocating, it takes working, but one of the things I found is that you just jump into the deep end of the pool and things will happen. Your legs will move, you'll keep yourself above the water, and I guarantee you, good things will happen from that. I can't tell you what they are because I didn't know what they were when we started. But I now can tell you with great confidence that if you jump into the deep end of the pool, things will happen.
And we have so much going for us, and we've come a long way. But every time we have a meeting, a research meeting, we walk out, Joe looks at me, I need to raise more money. There's a lot more work to be done. So yes, and that's why together we stand, right? That's the whole theme of this conference. We need to really stick together now more than ever, even though it feels like we're almost, making leaps and bounds, but we need to do everything that every single one of us can and is willing to do in order to keep going.
And let's end on that note. If your question did not get answered, please take that question to your small group. The small group discussions are coming up in just a few minutes, 4 o'clock. So keep that in mind, okay? We tried to get to everybody, but we ran a little short. That was a lot of questions. Thank you all so much for all of your input. Now, take a look at the screen here. Before we do that, let's just say thank you again to Dr. Mirza and Dr. Chung and Joe and Carol. The insight is truly incredible, so thank you all so much, so very much. All right, we're going to have a break until 4 o'clock, then you have your small groups.